Good evening, everyone. Good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So, my dear students, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Let me know quickly in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Good evening, people. Good evening. Good evening. Good evening, and welcome back. Good evening, and welcome back. Quickly, people in the chats. Quickly, let me know in the chats. Am I perfectly audible, visible to everyone? I would want everyone to let me know. All right, people. So, as I had promised, I will be taking a session. And it's going to be your complete chemistry revision in almost like 100 MCQs. And my dear students, in your Re-NEET examination, you should find your questions directly, indirectly from this session, and particularly from the sessions which I'll be taking in coming 2 days, right? As I told you, every day, exactly at 9 p.m., I have scheduled a session till your Re-NEET. And my dear students, your paper should be coming from these sessions only. That's my assurance to you. Okay? All right? So please and please do take these sessions seriously because they are super amazing sessions, right? Because we select all the questions, whatever questions we give to you in the sessions, whatever questions we solve in the sessions. These are hand-picked sessions based on our experience, right? If you would have seen the May 3rd paper, almost 15 to 16 questions were directly repeated from the sessions which I took at the end. So same thing, I'm pretty much sure is going to happen this time as well. So I would want you guys to take these sessions very seriously so that you can get benefited out of these sessions. Okay? All right, before starting the session, people are saying what is going to be the duration of the session. My dear students, duration of this session is going to be 2 hours. 2 hours, not more than that. Don't worry. The duration of this particular session, today's session is just going to be 2 hours, not more than that. Okay? Do not worry. I just want to know in the chats which part of the country you guys are watching me from right now. Which part of the country you guys are watching me from right now? I just want to know that first. After that, I'll be starting the session. Let me know, people, quickly in the chats. Let me know in the chats. I just want to know that. I can see people are watching us from... What is happening? My video is getting stuck. Is anything wrong? I think now it's fine. Okay, see, I can see people are watching us from Tamil Nadu, Kerala, UAE, Assam, Pondicherry, Karnataka, Uttar Pradesh, West Bengal, Telangana, Kuwait, Maharashtra. Okay. Kashmir, Karnataka. Okay, Andhra Pradesh, Chhattisgarh, Jaipur, Mizoram, Dubai, Chennai. That's great. That's great. All right, people. All right. All right. All right. Can you just tell me once in the chats again? Is everything clear? Like audio, video, no lag, nothing, right? Is it fine now? Is it fine now? Can you just give me quickly some fire emojis in the chats if every single thing is perfect? Yeah? Just let me know once the chat's quick. Let me fix the screen a bit. I think now every single thing is perfect. All right, people. So without wasting a lot of time, let's get going. Let's get started with this amazing session, my dear students. Okay. By the way, tomorrow at 9 p.m. Tomorrow at 9 p.m. there is one more amazing session. Okay. Do not miss that particular session at all. Do not miss that particular session at all. Tomorrow at 9 p.m. So what is the paper difficulty level as per you? As per me, the paper is going to be easy. Do not worry. Paper is going to be easy. It's not going to be tough. That's something which I believe. Okay. I think paper is going to be easy. It's not going to be tough. Hello guys, let's get going. Let's get started with the first question which is on your screen. Look at the question carefully, guys. Look at the question carefully and let's try to solve this particular question. If you look at this particular question, my dear students, a gaseous mixture of propane and butane, a gaseous mixture of propane and butane of volume 3 liters on complete combustion produces 10 liters of carbon dioxide at STP. Calculate the volume of propane in the mixture. Calculate the volume of propane in the mixture. Let me make you understand what this question is all about and how do I deal with such kind of the question. Understand properly, my dear students, what I'll be saying. First of all, my dear students, as far as the question is concerned, imagine that you have got a container. And in this particular container, you have kept two gases. One is going to be your propane, C3H8. And with propane, you have kept butane. Butane is C4H10. So basically, in the container, you have got two gases. One is propane, one is butane. As far as the question is concerned, volume of this gaseous mixture is how much? 3 liters. Volume of this gaseous mixture is 3 liters. Now, my dear students, the question is saying the gaseous mixture undergoes combustion. And when the gaseous mixture undergoes combustion, 10 liters of carbon dioxide gas are produced. This gaseous mixture is undergoing combustion, and when the gaseous mixture is undergoing combustion, the volume of carbon dioxide gas that is getting produced is equal to 10 liters. We have to check the volume of propane present in the mixture. Try to understand how I'm going to deal with this question. Understand properly, guys. First of all, the volume of this entire mixture is 3 liters, right? Let's assume out of 3 liters, there are X liters of propane here. That means 3 minus X liters will be the volume of butane here in this mixture. So basically in this mixture, let's assume we have got X liters of propane and we have got 3 minus X liters of butane in the container. Now, my dear students, the mixture is undergoing combustion. What is meant by that? That means in this container, you are adding O2 gas. In this container, you are adding O2 gas. Now, my dear students, the O2 gas which you are adding, I believe that O2 would be reacting with this as well as this. So I would say propane will be undergoing combustion in presence of oxygen. Also butane will be undergoing combustion in presence of oxygen. So how many reactions will be taking place here? I'll say 2 reactions will take place. The first reaction is going to be C3H8, which was there in the container. It will react with O2. It will lead to the formation of carbon dioxide, and with carbon dioxide you get water as well. Similarly, butane in the container, C4H10, butane in the container. It's also going to react with O2 and it will form carbon dioxide and water as well. Now look, if the reactions are balanced or not. Check if the reactions are balanced or not. My dear students, this is 3 here, so make it 3. This is 8, so this will be 4 times and this will be 5 times. The reaction is balanced. Similarly, if you look at this reaction, if I need to balance it, this I'll make 4 times, this I'll make 5 times, this I'll make 13 by 2 times. The reaction is balanced. Both the reactions are balanced, right? Now people, as far as the question is concerned, mixture contains 2 gases, propane and butane. You are adding O2 in the container. That O2 is reacting with propane as well as butane. When O2 reacts with propane, it leads to the formation of carbon dioxide gas. When butane reacts with O2, it leads to the formation of carbon dioxide gas. That means this 10 liter carbon dioxide which is getting produced as per the question, I would say some of the liters out of the 10 liters, some of the liters of carbon dioxide will be getting produced from this reaction and some of the liters of carbon dioxide will get produced from this reaction. Now let's use the stoichiometry. Understand? Stoichiometric option here is 1, here it is 3. Stoichiometry is telling me that 1 liter propane, when 1 liter propane undergoes combustion, 3 liters of carbon dioxide gas is produced. Stoichiometry is telling me that. But in the container, did we have 1 liter of propane for the combustion? No. there were X liters. So I would say when X liter propane undergoes combustion, 3X liters of carbon dioxide gas will get produced. So this is the volume of carbon dioxide which is getting produced from reaction number 1. Similarly, stoichiometric coefficient here is 1, here it is 4. So stoichiometry is telling me that when 1 liter butane undergoes combustion, 4 liters of carbon dioxide gas is produced. This is something which stoichiometry tells me. But my dear students, in the container, did we have 1 liter of butane? No, we had 3 minus X liters of butane. So when 3 minus X liters of butane undergoes combustion, I would say 4 into 3 minus X liters of carbon dioxide gas gets produced, right? So this is the volume of carbon dioxide which is getting produced from reaction number 2. What is the total volume of carbon dioxide produced as per the question? That is 10 liters, right? So can I use a simple concept? Volume of carbon dioxide produced from reaction number 1, that is 3x, plus volume of carbon dioxide produced from reaction number 2, that is 4 into 3 minus x, has to be equaled total volume of carbon dioxide, that is 10 liters, right? Now, my dear students, do the calculation. 3x plus 12 minus 4x is equal to 10. So I'll say x is nothing but 2 liters. And what was this x exactly? This x was the volume of propane which was there in the container. My dear students, expect the similar sort of question in your upcoming NEET examination as well. Am I clear with this? Yes or no in the chats quickly? Am I clear with this? Yes or no in the chats quickly, my dear students? Everyone. Everyone. Let me know quickly in the chats if I'm clear with this particular question. Did you understand? All right. All right. Moving on to the second question, people. I hope this particular question is clear. I'm moving on to the next question. Look at this question. The question is saying equivalent mass of H2O2. Equivalent mass of H2O2 in this particular reaction. This is something which I believe everyone should be able to solve because I've taught this concept many a times. Many a times I've taught this concept. Equivalent mass of H2O2 in this particular reaction. How do we solve this? See guys, understand properly. First of all, we have to calculate equivalent mass of H2O2. Can I say equivalent mass of H2O2 would be equal to molar mass of H2O2 divided by n factor of H2O2? Absolutely. Now think properly. What is the oxidation state of oxygen in hydrogen peroxide? You all must be knowing oxidation state of oxygen in hydrogen peroxide is -1. Here it is -2 and here it is 0. Correct? Now people look carefully. Is the oxidation state of oxygen increasing or decreasing? Is the oxidation state of oxygen increasing or decreasing? Check it out. -1 to -2, decrease in the oxidation state. -1 to 0, increase in the oxidation state. I would say oxidation state of oxygen is increasing as well as decreasing simultaneously. Right? Oxidation state of oxygen is increasing as well as decreasing simultaneously. So I would say this particular species undergoes disproportionation. And if this species undergoes disproportionation, how do you calculate its n factor? Its n factor is simply going to be n1, n2 divided by n1 plus n2. n1, n2 divided by n1 plus n2. Now, my dear students, what is the value of n1 and what is the value of n2? -1 to -2. -1 to -2. What is the change in the oxidation state? -1 to -2. Change is 1. 1 is the change for 1 atom of oxygen. I have 2 atoms. So 1 into 2 comes out to be 2. So n1 value is equal to 2. Similarly, -1 to 0. -1 to 0. What is the change in the oxidation state? Final minus initial. The value is 1. 1 is the change for 1 atom. I have 2. So n2 value is also 2. So n factor is going to be 2 multiplied by 2 divided by 2 plus 2. The value comes out to be 1. So n factor of H2O2 you got to know as 1. And my dear students, if n factor of H2O2 here is 1, you can easily calculate the equivalent mass, which is nothing but molar mass of H2O2. 34 grams, n factor is 1. So this is going to be the final answer of the question. I believe this particular question is clear to every one of you. Yes? Let me know quickly in the chats. Everyone. Moving on to the next question, guys. Moving on to the next question. The next question is from the chapter Thermodynamics. Look at the question carefully and give it a try. Look at the question carefully and give it a try, people. Quickly. Quickly. What do you think about this one? The question is in a closed insulated container. They are mentioning the term insulated. Insulated means Q value is 0. Insulated container. A liquid is stirred. You are stirring a liquid. You are stirring a liquid with a paddle. You are stirring a liquid. So liquid you are stirring, that means liquid is my system. Liquid is my system. And you are stirring the liquid. If you are stirring the liquid, that means work is done on the liquid. Work is done on the liquid. Work is done on the system. Right? Work is done on the system. Which of the following is correct? Pretty much simple. Q value is 0. Use the first law of thermodynamics. Delta U is equal to Q plus W. Right? If Q value is 0, that means your delta U has to be equal to W. Will W be 0? I told you already. Work is done on the system. If work is done on the system, that means W value is non-zero. If W is non-zero, since delta U is equal to W, W is non-zero, that means delta U is also non-zero. So my option will be Q is equal to 0, delta U is equal to W, both are non-zero. Q is equal to 0, delta U is equal to W, both are non-zero. It's directly option A, that will be the correct answer of the question. Yes, it's directly the option A, my dear students, which will be the correct answer of this particular question. I believe it's clear to everyone. Yeah? Perfectly done? Absolutely, absolutely, amazing. Tell me the answer of this question. It is a J mains asked question basically. And you just have to understand the language of the question, that's it. You just have to understand the language of the question. The question is delta U is equal to isothermal work, isobaric work, adiabatic work, isochoric work. What do you think? Delta U is equal to isothermal work, isobaric work, adiabatic work, isochoric work. My dear students, just use the first law of thermodynamics. You know, delta U is equal to Q plus W, right? Now, when can be delta U equal to work? I would say delta U can be equal to work only if Q is 0. I would say delta U will be equal to W only if Q is 0. And in which process Q is 0? That process is called as adiabatic process, right? So I would say delta U is nothing but delta U is equal to adiabatic work. Option C, that is the correct answer of the question. Right? Am I clear? Be careful with this sort of a question as well. A lot of students are going to make mistake here. I'm telling you. Yes? Perfectly done. My dear students, moving on to the next question. Moving on to the next question. Look at this particular question carefully. Look at this particular question carefully. Standard entropy of X2, Y2 and XY3 are given to us, right? The reaction is also given to us in the balanced format. Delta H for the reaction is given to us as well. What do we have to calculate? What do we have to calculate? For this reaction to be at equilibrium, the temperature should be. Now, first of all, for any reaction to be, for any reaction to be at equilibrium, I would say my condition is delta G has to be equal to 0. Delta G for the system has to be equal to 0, right? Then only there will be equilibrium. Now, delta G is what? Delta G is nothing but delta H minus T delta S. So this value has to be equal to 0. Now, since we are talking about the reactions, so let's write it as delta H reaction, delta S reaction. So I would say your delta H has to be equal to T delta S. Your delta H has to be equal to T delta S, or I'll say T has to be equal to delta H for the reaction divided by delta S for the reaction. Now, delta H for the reaction is given to me in the question, but delta S for the reaction, entropy change for the reaction, is not given to me. So my point will be to calculate entropy change for the reaction. And entropy change for the reaction is nothing but that is entropy of products minus entropy of reactants. So how do I calculate this entropy change for the reaction? Entropy of products. Stoichiometric coefficient is 1. 1 multiplied by entropy of XY3 minus entropy of reactants. Stoichiometric coefficient here is 1 by 2. Entropy of X2 plus this is going to be 3 divided by 2 and it's going to be entropy of Y2. Perfect. Now, my dear students, put the values and get the entropy change of the reaction. Entropy of XY3 as per the question is equal to 50 minus 1 by 2 times. Entropy of X2 is 60, right? Plus 3 by 2 times. Entropy of Y2 is 40. Now, I need to do a bit of calculation here. This is 50 minus, this is going to be 30 plus 4, 3, 12. 12 divided by 2 is 60. 60 plus 3 is 90. So the value comes out to be minus 40. The value comes out to be what? The value comes out to be minus 40, minus 2. Minus 40 and answer is going to be in joules per Kelvin, right? So this is the value of delta S. Since I got the value of delta H as well, that's given in the question, delta S is also there. So delta H is equal to minus 30 kilojoules. Delta H is equal to minus 30 kilojoules, which will be equal to minus 30,000 joules, divided by delta S for the reaction is minus 40 joules per Kelvin, right? So the value comes out to be 750 Kelvin. So I would say at temperature 750 Kelvin, at temperature 750 Kelvin, I would say the reaction will be at equilibrium. I believe this sort of a question is clear to everyone. Yes? Expect a similar sort of question in your exam. This sort of a question, I believe it has got the probability to be asked in the examination. I feel so. Because 2 consecutive years, same question has been repeated in your JEE Mains examination. So I believe this sort of a question can be asked in your Re-NEET examination as well. That's why I came up with this question again. Look at the question carefully. My dear students, you are given with a balanced chemical equation. XA gives YB. XA gives YB, right? And some data is also given to us. We just have to get the value of X and Y. We just have to get the value of X and Y. Tell me one thing. Tell me one thing. What would be the rate of reaction with respect to A? I'll start with the minus sign. 1 divided by X. Then I'll write change in the concentration of A divided by time interval delta T. So this is the rate of reaction with respect to A. Similarly, rate of reaction with respect to B. I'll start with plus 1 divided by stoichiometric coefficient Y, change in the concentration of B divided by time interval delta T. So this becomes my equation number 1. This becomes my equation number 1. Now I'll use the given data. Look at the question carefully. My dear students, this term is given in log form. This is in log form. This is not in log form. So let me convert this in log form. So it's going to be log of minus delta A divided by delta T is equal to log of delta B upon delta T plus 0.6 is nothing but that is log of 4. Log of 4. So I would say log of minus delta A divided by delta T is equal to log of M plus log of N. Log of M plus log of N is nothing but log of M into N. So it's going to be 4 multiplied by delta B upon delta T, right? If I take NT log on both the sides, it's going to be minus delta A divided by delta T is equal to 4 times delta B upon delta T. Now people, if you take 4 here in the denominator, it becomes minus 1 by 4 delta A divided by delta T is nothing but delta B divided by delta T. Now, if you compare both the equations, this equation and this equation, my dear students, after comparing delta A by delta T, delta A by delta T, minus 1 by X, minus 1 by 4, that means after comparing X values coming out to be 4. Here it is 1 by Y, here it is 1 by 1. So Y value is nothing but 1. This sort of a question, I believe, can be asked in the examination. Did you understand how do we deal with such kind of a question? Did you understand how do we deal with such kind of a question, people? I believe yes. Again, one more question. One more question. One more question. Look at the question carefully, guys. The slope of ln K versus 1 by T. The slope of ln of K versus 1 by T. For a first order reaction is given. Ln K versus 1 by T. Right? Calculate activation energy in kilojoules. My dear students, remember your Arrhenius equation. Remember your Arrhenius equation. There is one of the forms of Arrhenius equation. Ln of K is equal to ln of A minus EA divided by R multiplied by 1 by T. Okay, perfect. Now, first of all, the slope of ln K versus 1 by T. Ln K versus 1 by T. Imagine ln K you are plotting along y-axis. 1 by T you are plotting along x-axis. This becomes my M value. Here the sign is minus. This becomes my C. Here it is equal. Y is equal to minus mx plus C. Y is equal to minus mx plus C. Right? Y is equal to minus mx plus C. So it's going to be a straight line with negative slope. Straight line with negative slope. And what is the slope exactly? Slope here is equal to minus EA by R. Slope here is equal to minus EA by R. And as per the question, the slope is given to me as minus 5 into 10 raised power 3. So minus minus cancels out. So I'll say EA is equal to 5 into 10 raised power 3 multiplied by R. Now I need the answer in kilojoules. I need the answer in kilojoules. So it's going to be 5 into 10 raised power 3. If I take the value of R as 8.314 joules per Kelvin per mole, I took the value of R in joules. So the answer right now will be in joules. But I need the answer in kilojoules. So I'm dividing this with 1000. Now I'll be getting the answer in kilojoules. This is going to be the final answer of the question. Understood? Is it clear? Everyone? Everyone, people? Everyone in the chats. Quickly, everyone in the chats. What do you think about this question? What do you think about this particular question? You're given 3 reactions. E value for first is given, E value for second is given, and you have to calculate E value for third. Again, this sort of a pattern can be asked in the examination. Now, what you have to do? My dear students, the reaction whose E value is to be calculated. The reaction whose E value is to be calculated. You are supposed to make that reaction. The reaction whose E value is to be calculated. You are supposed to make this reaction from those reactions whose E value is given to us. Okay? Right? My dear students, the reaction whose E value is given. You are supposed to make this reaction from those reactions whose E value is given. Yeah? Right? Now guys, try to understand. If you look carefully, this is your equation number 1. This is your equation number 2. This is your equation number 3. So technically you have to make equation number 3 from 1 and 2. How do you make equation number 3 from 1 and 2? If you just add 1 and 2, so Cu positive cancels out. So I'll get copper dye positive plus 1 electron makes it 2 electrons, gives copper. So basically third reaction I'm getting when I'm just adding 1 and 2. Third reaction I'm getting when I'm just adding 1 and 2. And my dear students, let me tell you, whatever operation you are doing with the reactions, same operation you have to do with the delta G values. So I'll say delta G for the third reaction will be equal to delta G for the first reaction plus delta G for the second reaction. Now you must be knowing delta G is nothing but delta G is equal to minus NFE cell. Delta G is equal to minus NFE cell, right? So delta G3 will be equal to minus N3FE3 is equal delta G1 minus N1FE1. Similarly, delta G2 minus N2FE2. So F everywhere cancels out. Multiply with minus sign. So finally you get E3 as N1E1 plus N2E2 divided by what? Divided by N3. Now my dear students, E1 is given to us in the question. E2 is given to us in the question. Now what is this N1, N2 and N3? N1 is the electrons in the first reaction. Electrons, N1 value is 1. N2 value is also 1. N3 value is 2. Right? N1 is equal to 1. N2 is equal to 1. N3 is equal to 2. Right? So put the values of N1, N2, N3 also here. You'll be getting the final answer of the question. So this is how you are going to approach to this sort of a question. Yes? I believe it's clear to everyone. My dear students, look at this particular question. The question is from the chapter redox reaction. The question is from the chapter redox reaction. And you can easily solve this question as well, provided you know the concept. My dear students, one thing I'm going to tell you. How do you calculate number of gram equivalents? Number of gram equivalents is nothing but number of moles multiplied by n factor. Number of gram equivalents of a substance. Number of gram equivalents of a substance is always equal. Number of moles of the substance multiplied by n factor of the substance. Now the question is 6 into 10 raised power minus 3 moles of K2Cr2O7. So you have got K2Cr2O7. How many moles of it? We are taking it 6 into 10 raised power minus 3 moles. So 6 into 10 raised power minus 3 moles of K2Cr2O7 reacts completely with what? Reacts completely with 9 into 10 raised power minus 3 moles of Xn positive. Xn positive. Its moles are 9 into 10 raised power minus 3. Right? As per the question, when K2Cr2O7 reacts with Xn positive, Xn positive gets converted into XO3 negative. The reaction is taking place in acidic medium. And you should know in acidic medium, K2Cr2O7 gets converted into chromium tripositive. In acidic medium, K2Cr2O7 gets converted into chromium tripositive. My dear students, let me tell you, in acidic medium, n factor of K2Cr2O7 is 6. In acidic medium, n factor of K2Cr2O7 is 6. Now, what is the n factor of this Xn positive? If I calculate the oxidation state of X here, it's plus 5. Here it is plus n. So plus n to plus 5. What is the change in oxidation state? Final minus initial. Final minus initial. This is the n factor of your Xn positive here. Right? Now, if you use the equivalent concept says that whatever equivalence of K2Cr2O7 would have reacted in the reaction, same equivalence of Xn positive would have reacted. So I can simply say one thing. The number of gram equivalents number of gram equivalents of K2Cr2O7, right? It has to be equal to the number of gram equivalents of Xn positive. Now, gram equivalents of K2Cr2O7 will be equal to moles of K2Cr2O7 multiplied by n factor of K2Cr2O7 is equal to moles of Xn positive multiplied by n factor of Xn positive. What is the value of N1? That is nothing but 6 into 10 raised power minus 3. N factor of this, that is 6, is equal to N2 value, 9 into 10 raised power minus 3. And N factor 2, that is 5 minus N. Look at all the terms which will get cancelled out, right? It's a matter of calculation now. You can easily get the N value from here. And whatever is the value of N, that is something you were supposed to calculate. Calculate N, right? Did you understand how do we deal with such kind of the question? Let me know once in the chat, people, quick. Did you understand how do we deal with such kind of the question, everyone? So you just have to equate their gram equivalents or milli equivalents. You'll be getting the answer. That's all. The question is based on the titration. Simple. Redox titration. This question, I believe, you should be in a position to solve easily. What do you think? What do you think about this one? What do you think about this one? And this question I would have solved many a times. You should be in a position to solve it on your own. You should be in a position to solve it on your own. My dear students, what transition in the hydrogen spectrum? What transition in the hydrogen spectrum would have the same wavelength? Would have the same wavelength as the Balmer transition n is equal to 4 to n is equal to 2 of He positive spectrum. Look at the question. So on one side, I'm writing hydrogen. On another side, I'm writing what? I am writing He positive. On one side, I wrote hydrogen. On another side, I wrote He positive. My dear students, in He positive, the electron is moving from n is equal to 4 to n is equal to 2. The electron makes a transition from n is equal to 4 to n is equal to 2. Now, you know when the electron makes a transition from higher energy state to lower energy state, it emits energy in the form of radiation. That radiation definitely would have some wavelength. Let that wavelength of the radiation emitted is lambda. Let the wavelength of the radiation emitted is lambda. Now, what should be the transition in hydrogen? What should be the transition in hydrogen? Such that the wavelength is equal to lambda only. What should be the transition in case of hydrogen? Such that the wavelength emitted would be same as what is emitted there. Now, I'm assuming, let the transition be from N2 to N1. Let the transition be from N2 to N1, right? Okay. So I'm assuming when the electron makes a transition from N2 to N1 here, it is going to emit the radiation whose wavelength will be same, lambda. Now, if I use the Rydberg's formula here, I will say 1 divided by lambda is equal to R, Z square. Z value is 1 upon N1 square minus 1 upon N2 square, right? If I use the Rydberg's formula here, it is 1 divided by lambda is equal to R, Z square. Z is its atomic number. Helium's atomic number is 2. 2 ka square is 4. R Z square 1 upon N1 square minus 1 upon N2 square. Perfect. So if you simplify this a bit, so it's 1 upon lambda is equal to R. This 4 and this 4 gets cancelled, right? So it's R into 1 by 1 minus 1 of the 4 gets cancelled here. So it's 4. Or you can write it as like this. 1 by lambda is equal to R. This is going to be 1 upon 1 square minus 1 upon 2 ka square. Perfect. Now compare the two equations, this equation and this equation. My dear students, when you compare the two equations, after comparing, I can get N1 value equal to 1 and N2 value equal to 2, right? So N2 here, after comparing, is coming out to be 2. N1 value is 1. So what does it mean? It means that in case of hydrogen atom, the transition should be from 2 to 1. Then only the transition should be from 2 to 1. Then only the wavelength emitted is same as what is emitted when the electron makes a transition from 4 to 2 in case of He positive. Okay. Again, a simple question from the chapter atomic structure, and I believe you can easily solve this sort of a question if it comes. Let me know once in the chats if it is clear. Let me know once in the chats if it is clear. Yes or no in the chats. Expect a question from nodes as well. Expect a question from nodes as well. Expect a question from nodes as well. First of all, the orbital that is given to me is 3p. It is 3p. What is the value of n here? The value of n is 3. What is the value of L for p subshell? For p subshell, the value of L is 1. How do we calculate total number of nodes? Total number of nodes is nothing but the formula is n minus 1. How do we calculate angular nodes? angular node is equal to the value of L. How do we calculate spherical nodes? Spherical node is simple, n minus L minus 1. Now put the values, that's all. N value is 3, 3 minus 1 is 2, right? L value is 1, so this is 1. Put the values, this will be also 1. That's all. Am I clear? So remember the formulas. I've given you this formula many a times and I believe you can easily kill it. This is again your J mains question, right? And question like this will be repeated in your examination as well. Okay? So tell me the answer of this question. You are given with the reaction. You have to get the value of Kp by Kc. You are given with the reaction. You have to get the value of Kp by Kc. My dear students, if I calculate delta Ng for the reaction, delta Ng will be equal to number of moles of gaseous product, which is 1, minus number of moles of gaseous reactant, which is 1 and 1 by 2, makes it 3 by 2. Number of moles of gaseous product minus number of moles of gaseous reactant. The value comes out to be minus 1 by 2. So delta Ng is minus 1 by 2, right? Now you know the result for a gaseous phase reaction, Kp is equal to Kc RT raised by delta Ng, right? So I can say Kp is equal to Kc RT raised by delta Ng is minus 1 by 2. So I can say Kp divided by Kc. Take this Kc in the denominator. It will be RT raised by minus 1 by 2, which is nothing but 1 divided by square root of RT. So it's option number C, which will be the correct answer of this question as well. Perfect. Am I clear? Am I clear? Everyone in the chats quickly. Quickly, my dear students, everyone in the chats. Am I clear with this? If I'm clear with this, we should be in a position to solve this one as well. We should be in a position to solve this question as well. Look at the question carefully. My dear students, we are given the reaction. Okay. The partial pressure of N2 and H2, 0.8 atm, 0.4 atm at equilibrium. The total pressure of the mixture at equilibrium is also given. Total pressure of the mixture at equilibrium is also given. We have to calculate Kp for the reaction. We have to calculate Kp for the reaction. How do I solve this sort of equation? First of all, how do you write the expression for Kp? You always start with the product. So you'll be writing partial pressure of NH3 at equilibrium raised par stoichiometric coefficient 2 divided by partial pressure of N2 at equilibrium raised par stoichiometric coefficient 1, partial pressure of H2 at equilibrium raised par stoichiometric coefficient, right? Yes. Now, my dear students, partial pressure of N2 at equilibrium is given to me. Partial pressure of H2 at equilibrium is given to me. What do I need? I need the partial pressure of NH3 at equilibrium. Now, first of all, when equilibrium is established in the reaction, there will be 3 gases in the container, right? N2, H2 and NH3. As far as the question, total pressure of the mixture at equilibrium is given to me as 2.8 atm. Total pressure of the mixture at equilibrium is given to me as 2.8 atm. I would say total pressure of the mixture as per Dalton's law will be the sum of the partial pressures. I'll say it is partial pressure of N2 at equilibrium plus partial pressure of H2 at equilibrium plus partial pressure of NH3 at equilibrium. This value as per the equation is 2.8, right? Now this value is how much? 0.8. This value is equal to 0.4. Now I'll be getting the partial pressure of NH3 from here. This is equal to 2.8. So calculate the partial pressure of NH3. Partial pressure of NH3 at equilibrium will be 1.680, right? Now put the values here. This will be 1.6 ka square divided by partial pressure of N2 is 0.8. Partial pressure of H2 is 0.4. When you solve this, the value comes out to be 50. So Kp for the reaction is nothing but 50, right? The question was pretty much simple. You just were supposed to write the Kp expression. Nothing more than that. Nothing more than that. Moving on to the next question, people. Moving on to the next question. Look at this question carefully. The question is from ionic equilibrium. The question is from ionic equilibrium. My dear students, calculate the ionization constant of a weak base, NH4OH. So you have got a weak base, NH4OH, and imagine that you are introducing this in water. If it is a weak base, it's going to remain in equilibrium with its ions. Ions will be NH4 positive aqueous, and with that, you'll be writing OH negative aqueous as well, right? Perfect. My dear students, at time t is equal to 0, let the concentration of NH4OH is C, right? And that's given to me in the question, 0.1 molar. This would be 0, this would be 0. Now at equilibrium, this would be C minus C alpha, this would be C alpha, this would be C alpha, correct? Now what I have to calculate? I have to calculate the value of Kb, ionization constant. And ionization constant Kb expression will be simply C alpha square divided by 1 minus alpha. Perfect. As far as the question is concerned, the concentration of OH negative. As far as the question is concerned, the concentration of OH negative is how much? That is 0.05. As per our calculation, concentration of OH negative is nothing but C alpha. So technically C alpha value is 0.05. So from here I can calculate alpha 0.05 divided by C. Now C value is given to me in the question. How much is that? That is 0.1. The value comes out to be 0.5. So you got the alpha value of 0.5. Right? If you got the alpha value, C is nothing but 0.1. Alpha ka square, that means 0.5 ka square, divided by 1 minus alpha, 1 minus 0.5. So this value after solving, this will be 0.5, 0.5, 0.5 cancelled. The answer will be 0.05. This is something which you were supposed to calculate. Okay. So remember this particular question as well. And remember its approach as well. Okay. Now guys, there is one more question from ionic equilibrium. If you look carefully, mercurous chloride, that is your Hg2Cl2. You just need to remember one thing. Hg2Cl2 undergoes dissociation in a special way. Hg2Cl2 undergoes dissociation in a special way. Remember that. Hg2Cl2, it undergoes dissociation as Hg2 dye positive aqueous plus 2 times Cl negative aqueous. This is how it undergoes dissociation. This does not undergo dissociation in the normal way. It undergoes dissociation like this. Now, let the solubility of this is S. This will be S. This will be 2 times S because the stoichiometric coefficient here is 2. Now, my dear students, if you want to write the expression for KSP, KSP expression is simply going to be concentration of Hg2 dye positive raised power stoichiometric coefficient 1, concentration of Cl negative raised power stoichiometric. Now, tell me one thing. KSP is equal. Concentration of Hg2 dye positive, that's S. Concentration of Cl negative, that is 2 times S raised power 2. The value comes out to be 4S cube. Right? So I would say your S value is nothing but it is KSP divided by 4 whole raised power 1 by 3 when you do its calculation. Now, as per the question, KSP value is given to me in the question, that is 10.8 into 10 raised power minus 23 divided by 4 whole raised power what? Whole raised power 1 by 3. Perfect. So this will be 2.7 into 10 raised power minus 23, or I can say 27 into 10 raised power minus 24 whole raised power 1 by 3. So 27 raised power 1 by 3 is 3 into 10 raised power minus 8 moles per liter. This is the solubility of mercurous chloride which you are supposed to calculate. Am I clear with this? Yes, I believe I'm clear. Now guys, some questions which you are going to love. Tell me. Carbon, nitrogen, oxygen, fluorine. The second ionization energy. The second ionization energy order. They are not talking about the first ionization energy. They are talking about the second ionization energy. They are talking about the second ionization energy. Quickly. If they are talking about the second ionization energy, that means in oxygen, you have to take electron out from 2p3 configuration. And 2p3 configuration, half filled. Right? More energy is required. Perfect. So definitely oxygen will have more second ionization energy than that of fluorine. I'll go with option number A only. Because that's only matching. I'll directly go with option number A. Because they are not talking about the first, they are talking about the second ionization energy. Okay? So the second electron in oxygen, you have to take out from 2p3 configuration, half-filled configuration. Half-filled configuration is more stable, so more energy is required. Okay? All right. Tell me the answer of this question. Tell me the answer of this question. Which of the following represents the correct trend? Which of the following represents the correct trend? Well, these can be 4 different questions asked, by the way. These can be 4 different questions asked. These can be 4 different questions asked. Give me the correct order. Which one has the correct order here? Quickly. Well, let me call KK sir till then, because he's ready with the organic questions. Okay, I'll just tell him to be ready, because I'll be done in like 10 to 15 minutes maximum. Ready here? The phone. All right, guys, tell me quickly. Majority of the students are giving the incorrect answer, guys. You have to give the correct order. Electron affinity, guys, electron affinity. Chlorine has got more electron affinity than that fluorine. It's option B. Is that? Is that? Is that? Which of the following represents the correct trend? Waiting for your answers. Quickly in the chats. Quickly, quickly, quickly. It can be more than one option correct as well. Hello, this question I'm giving you as the homework. Do let me know its answer in the comment section. Okay? Could be more than one correct as well. Okay? Ionization energy, electron affinity, metallic character, and basic character. I would need its answer in the comment section. Till then, you can tell me the answer of this question. Quick. Quickly, guys, quickly. SF4. What is the type of SF4 molecule? That is AB4L1, right? SF4 molecule is AB4L1, correct? AB4L1. That is isostructural with what? If you look at SF4, the type of SF4 molecule is nothing but AB4L1. Okay? Now, you have to check that particular molecule here, whose type will be again AB4L1. If I select this one, I have 4 positive. If I select this one, I have 4 positive. When you check its type, it's again AB4L1 only. It's again AB4L1 only. So these two are isostructural, the 4 and this one. Okay? One more question. Pair of species having same bond order. You know, again, isoelectronic species will have the same bond order. Now, which one are isoelectronic here? Check it out. Which one are isoelectronic here? Check it out. Which one are isoelectronic here? The ones which have got same number of electrons. O2 positive, 15 electron species. N2 negative, 15 electron species. These two are isoelectronic, same number of electrons. So their bond order will be same. Okay? Tell me the answer of this particular question. Which are not true about XeO2F2? XeO2F2, my dear student. XeO2F2. Seesaw shape. Seesaw shape. This is the structure of your XeO2F2. XeO2F2. This is the structure of it. Now, from the structure, you can easily check which one is not true. It is a seesaw shape. OXeO bond angle is closer to 180. OXeO. Is this bond angle closer to 180? No. So this is incorrect. Right? That's something you were supposed to check. All right, one more. Number of molecules or ions in which the central atom is sp3 hybridized. Tell me, where do you think central atom is sp3 hybridized? This is NO3 negative. NO3 negative, right? Nitrogen here, is it going to be sp3 hybridized or sp2 hybridized? I just want to know that. Quickly, NO3 negative, sp2 or sp3? It is sp2 hybridized, right? PCl3, Boron here will be again sp2 hybridized. ClO2 negative. ClO2 negative. 2 sigma bonds, 2 lone pairs. sp3 hybridized. ClO3 negative. ClO3 negative. 3 sigma bonds, 1 lone pair. sp3 hybridized. Right? sp3 hybridized. Perfect. Now we can check. You're done. You're done. Okay. Which of the following exhibits maximum boiling point? Which of the following exhibits maximum boiling point? Urea does not undergo dissociation. NaCl undergoes dissociation. BaCl2 undergoes dissociation. This also undergoes dissociation. So which one is going to give more ions? Which one will give more ions? This is going to give the maximum ions. Right? If it is giving the maximum ions in the solution, it will have maximum boiling point. Boiling point is directly proportional to number of ions produced. Okay? Directly proportional to number of ions produced. Look at this question. For the reaction A gives B, your rate constant is given. Calculate the time taken for 3/4 of completion. Calculate the time taken to complete. We have to calculate time taken to complete 3/4 of the reaction. 3/4 of the reaction. 3/4 means what percentage of it? 3/4 means 3 by 4 into 100. Will come out to be what? 75%. So technically we are supposed to calculate time taken to complete 75% of the reaction. Do you know time taken to complete X% of the reaction is nothing but 2.303 divided by K log of 100 divided by 100 minus X, and X is how much? 75%. So it will be 2.303 divided by K. K is how much? K is 2.303 into 10 raised power minus 3, and it's going to be log of 100 divided by 25 is 4. 100 divided by 25 is 4. And log 4 is how much? 0.6. Log 4 is 0.6. This got cancelled. The answer is approximately 600 into 10 raised power 3. The value will be 600. So time taken to complete 3/4 of the reaction. Time taken to complete 75% of the reaction will be 600. Okay. Well, this is the last question, people. After this question, your organic will start. And it will be started by KK sir. And the question that I gave you as the homework, I would want its answer in the comment section of the video. Tell me. Boron, thallium, gallium, aluminium, indium. This is the order of what? This is the order of your ionization energy. Okay. Chlorine, fluorine, bromine, iodine. This is the order of your electron affinity. Chlorine, chlorine, bromine, iodine. This is the order of your electronegativity. Boron, gallium, aluminium, indium, thallium. This is the order of your atomic rate. You are supposed to match them. And you are done. You are sorted. Okay. Now, just be with me. Your KK sir is joining in, and he has come up with almost 50 organic chemistry questions. 50 organic chemistry questions he'll be solving with you, okay? Right? Akar's start, but your end.
Hello, my dear lovely students. I'm sure you're all doing wonderful, and hopefully you will come out victorious on 21st June. Before we move ahead, let me know in the chats if I am perfectly audible and visible to each one of you. Let me know in the chats quickly. Let me know in the chats quickly if I am perfectly audible and visible to each one of you. Okay, my dear lovely students, so let's begin our session with some amazing questions today. So without wasting time, let's get started. So first question is, X is the product which is obtained by hydrolysis of prop 1 ion. That means you are having prop 1 ion. Prop 1 ion is this one. This upon hydrolysis. That means H2O, Hg dipositive, H2SO4. It undergoes and it results in the formation of product X. Now, it results in the formation of product X. Then, Y is the product which is obtained by reaction of ethane nitrile. Ethane nitrile is this one. Ethane nitrile is this one. Now, this is ethane nitrile. It gives Y when It is treated with methyl magnesium bromide in dry ether, followed by hydrolysis. So this is why. Then question says, IUPAC name of the product obtained when X and Y in presence of barium hydroxide. That means when X and Y are treated with barium hydroxide, there will be a product, and say for example that product is P. You have to tell me the name of that product. Have a look. It's very simple, very simple reaction. Have a look. It's basically your propine which upon hydrolysis yields what we call acetone. It is CH3, C double bond O, and then CH3. So this is our X, and this is taking place in presence of Hg2 positive, H2SO4. So this is X. After that, you are having ethane nitrile. This ethane nitrile on treatment with methyl magnesium bromide, that means it's like this. This is Grignard's reagent, negative part, positive part. This negative part will attack this will break, and it will first result in the formation of CH3, C double bond N having negative charge, MgBr with a positive charge. Here it will be CH3. This upon hydrolysis yields simply that we will get acetone over here once again. So this is, I mean to say, Y. Now, X is acetone, Y is acetone. These two acetone molecules, have a look. These two acetone molecules on treatment with, have a look. This is also acetone. This on treatment with barium hydroxide followed by heat. That means this is simple, what we call intermolecular aldol condensation. So it will result in the formation of CCH3. That water is lost, then it is CH, then it is C double bond O, then it is CH3. So it will be like this. This will be the product. So what is the IUPAC name of this? 1, 2, 3, 4, 5. So it is 4-methyl. Then it is pent 3N, then 2-on. Have a look. What is the answer of this question? 4-methyl pent 3N 2-on. So this is the option, 4-methyl pent 3N 2-on. Have a look. It is 4-methyl, then it's pent, then it's 3N, then it's 2-on. So our option number 2 is the correct answer. I hope this point is clear to each and everyone. After that, dear students, there is another question. An optically active alkyl bromide having formula C4H9Br. First of all, let me tell you that we are having C4H9Br. C4H9Br can be like this. C4H9Br can be like this. C4H9Br can be like this. I hope this point is clear. After that, C4H9Br can also like this. This can be C4H9Br as well. This can be C4H9Br as well. But among these, which one is optically active? Optically active is this one. Now, question says an optically active alkyl bromide having formula C4H9Br, that means it's 2-bromobutane, reacts with ethanolic KOH. Have a look. So it is 2-bromobutane. This is having one chiral center, so the molecule becomes what we call chiral and optically active. This on treatment with alcoholic KOH, I mean say ethanolic KOH, can I write down, instead of ethanol, can I write down directly alcohol? Alcoholic KOH is there. That means this is simply what we call E2 reaction. And major product will be formed from this beta as compared to this, because this will form Hoffman, this will form Sadzef product will be the major product. So this is the product. This is the major product formed. Now, this is butene. After that, this is what we call to form a major product A. So this is our A. After that, question says, which reacts with bromine to give compound B? This on treatment with bromine gives compound B. That means it will give vicinal dibromide. it will give vicinal dibromide. Bromine will be added across carbon-carbon double bond. Now, this is compound B. After that, dear students, B reacts with ethanolic KOH. Once again, alcoholic KOH and sodamide. Alcoholic KOH and sodamide means it is two consecutive. This is two consecutive E2 reactions. So, two E2 reactions you have to perform over here. That means first dehydrohalogenation, then dehydrohalogenation. So, it will result in the formation of alkyne directly. It results in the formation of alkyne directly. So, this is compound C. So, alkyne is RC. After that, dear students, one molecule of water adds to compound C on warming with mercuric sulfate and dilute sulfuric acid at 333 Kelvin to form compound D. Have a look. This on treatment with water, that means hydration, HgSO4, H2SO4 at a temperature of 333 Kelvin gives what we call compound D, and we know compound D is CH3, C double bond O, CH2, CH3. This is compound D. Now, after that, the functional group in the compound D will be, this is ketone. Now, it can be confirmed by haloform test. Answer is yes, because aldehyde or ketone having this group shows haloform test. That means this is confirmed by haloform test. Answer is haloform test is correct one. Lucas test. Ketones do not show what we call Lucas test, because Lucas test is used to distinguish 1 degree, 2 degree, 3 degree alcohol. Silver mirror test. No, this is given by only aldehydes, not ketones. Benedict's test. It is not given by ketones at all. That means first option is the right answer. After this, my dear lovely students, we are having this question. You are having a structure like this. Then it is O, then it is CH2, then it's having one more phenyl ring. Now this on treatment with HI at high temperature, what will happen over here? This is phenolic oxygen, so this oxygen carbon bond is difficult to break because this is strong bond due to partial double bond character. That means we will simply break this bond. We will give H to this and I to this. That means one of the products will be always phenol here and another product will be benzyl iodide. CH2 and I will be here. So question says, have a look towards the question. Statement 1. In the above reaction, product formed will be a mixture of benzyl alcohol and iodobenzene. Is this benzyl alcohol and iodobenzene? No. This is phenol and what we call benzyl iodide. That means statement 1 is incorrect. Then statement 2. In the above reaction, OCH2 bond is cleaved. Have a look. OCH2 bond is cleaved. Yes, this is exactly correct. Okay, to give the product. Now, tell me, statement 1 is incorrect, statement 2 is correct. Statement 1 is incorrect, that means statement 1 is false, but statement 2 is what we call true. So, option 4 is the right answer. After this, question is like this, have a look. Question is like this. You know, whenever you are having what we call a carboxylic acid, this carboxylic acid on treatment with ammonia followed by heat, you know, carboxylic acid is converted to amide. It forms amide. Now, on this amide on treatment with NaOH and Br2, that means this is Hoffman bromamide reaction. What will happen? Remove this, say C double bond O. If you remove C double bond O, we will get this one. We will get this one. I hope this point is clear. After that, it is treated with, HNO2 and then what we call H2O. We will get alcohol. Because amines on treatment, primary aliphatic amines on treatment with nitrous acid results in the formation of primary alcohol. I hope this point is clear to you. So it's having 1, 2, 3 carbons over here. It's 1, 2, 3 carbons over here, but here it's only 2 carbons. Here only 2 carbons are there because it will be, say C double bond O will be lost. So it will result in the formation of this amine and then this alcohol. Now, this alcohol on treatment with benzene diazonium chloride, have a look. It's benzene diazonium chloride at a temperature of 0 degrees Celsius. What will happen? Now this N2 will be replaced. N2 will be replaced by hydrogen. So we will get, say benzene. So benzene is the right answer of this question. After this, we will be having this compound like this. It is CHO, then it is CHOH, then it is, I mean to say, CH2OH. This on treatment with HI and what we call heat. As you know, HI is a very strong reducing agent. It will convert this into hexane. It will form this one. It will form this one. Normal hexane, I mean say N-hexane will be obtained. Now N-hexane on treatment with V2O5 at a temperature of 773 Kelvin and at a pressure of 10 to 20 atmosphere, what will happen? Aromatization will take place and N-hexane results in the formation of benzene. Now this benzene on treatment with benzoyl chloride, in presence of AlCl3, that means this is Friedel-Crafts benzylation reaction, Friedel-Crafts acylation reaction, and we will get simply benzophenone. We will get simply what we call benzophenone. Now question says major product, total number of electrons in pi bonds and lone pairs. Total number of electrons in lone pairs is 4. In pi bonds, 1, 2, 3, 4, 5, 6, 7 pi bonds are there. So 7 pi bond means 14 electrons and 4 lone pairs. That means in total there are 18 electrons. I hope this point is clear. After that, given below are two statements. This is carbocation, this is carbanion. Carbocation is stabilized by, obviously carbocation is stabilized by plus R of this OCH3 group. This is OCH3 group and this is a carbocation over here. So this carbocation is stabilized by, obviously electron donating group. This is stabilized by electron donating group. You know this. Now, here it is NO2. NO2 is electron withdrawing. It will destabilize carbocation. Now, statement 1 says, in this, the carbocation is stabilized by plus R of OCH3. Exactly correct. And this is another statement. Have a look. Let me show this structure first. This is a carbanion. My dear lovely students. This is a carbanion. Now have a look. Same groups are attached. OCH3 is plus R, NO2 is minus R. Now in this carbanion, the carbanion is stabilized by minus R of NO2. Exactly, both statements are correct. This is stabilized by plus R of OCH3 and carbanion is stabilized by minus R of NO2. That means both statements are correct. Both statement 1 and 2 are exactly true statements. Now after this, question is like this, but let me know in the chats, is this visible to each and everyone? Is this slide visible to each and everyone? Yes, this is visible to me. That means this is visible to each and everyone there. Now, have a look. First of all, it is C2H5, then it's phenyl ring, then it's NO2. You have to perform bromination. With the help of these two, electrophile will be Br positive, and that electrophile will come to, say, ortho position. That means it will be like this. It is C2H5 over here. Then bromine will come to this position and this is NO2. Now, my dear lovely students, this is A. Then this NO2 will be reduced by tin HCl. So it will result in the formation of a structure, and that structure B is like this. C2H5, then it is Br, then it becomes NH2. This is B. Now this NH2 on treatment with NaNO2 HCl means diazotization reaction. So NH2 will be converted to N2Cl. Say diazonium chloride. So it will be like this. Now this diazonium chloride on treatment with alcohol, this N2 group will be replaced by H. It will be replaced by hydrogen. That means we will get this one, C2H5. Now this C2, this is D, C2H5 on treatment with KMNO4 KOH, and after that hydrolysis, so it is converted to COH. That's it. So this is what we call our E, or the final product. The question says, what is A and E? A is this one, that means this one, and E is this one. So this is the correct answer. After that, statement 1, methane can be prepared by decarboxylation of soda lime, by decarboxylation of, sodium ethanoate. Have a look. This is sodium ethanoate. This on treatment with soda lime, NaOH heat, we know it will result in the formation of CH4 plus Na2CO3. So this part is correct, that methane can be prepared by decarboxylation of sodium ethanoate. Then in the same statement, Kolb's electrolysis of or Kolbe's electrolysis of sodium acetate, that means once again same structure. Sodium acetate upon Kolbe's electrolysis results in the formation of what? We know this bond will be broken and it will result in the formation of methyl radical. Then that methyl radical undergoes coupling or combination and results in the formation of ethane. So this cannot form what we call methane. That means with the help of this statement 1 becomes incorrect. Now second, methane cannot be prepared from unsaturated hydrocarbons by Wirtz reaction. Second is exactly correct, but statement 1 is incorrect. So statement 1 is incorrect, second is true. So it is like this. It is like this. So statement 1 becomes incorrect because of this reaction. After that, there is match list 1 and 2. Number 1 is scurvy. Scurvy is because of which vitamin? It's because of ascorbic acid. Then convulsion. Convulsion is because of pyridoxine. Then chelosis. Chelosis is because of riboflavin. Then xerophthalmia. Xerophthalmia is because of what we call vitamin A. That means it's this one. It's A, 3, yes. Then B, it's 1, yes. Then chelosis, C, then it's 4. After that, D is 2. Exactly. After this, we have another reaction. Match 1 with 2. Now, whenever benzene diazonium chloride is treated with cuprous chloride, reaction is simply known as formation of chlorobenzene. Reaction is known as Sandmeyer's reaction. So A is 4. A is 4 means it's option 1. No need to check others because A4 is only 1. But let me tell you another. This is known as what we call Gattermann reaction. Gattermann reaction. That means B is 3. B is 3. This reaction is known as basically Bals-Schiemann reaction. So C is 2. C is 2. And this reaction is known as coupling reaction. That means D is 1. Obviously, it's option number 1. Now, have a look. Have a look. Question says that you will get symmetrical tribromobenzene. Say for example this one. Tribromobenzene. Symmetrical tribromobenzene. But it has been formed by boiling with ethanol. That means ethanol is there. We know ethanol can convert diazonium salt. Ethanol can remove N2 of diazonium salt by hydrogen. So this has been removed by this with the help of this. That means this will be replaced by hydrogen with the help of ethanol. So this is actually Z. Now this Z has been formed. Benzene diazonium salt will be formed from which species on treatment with this sodium nitrite and HCl. That means what should be Y? Y should be obviously here NH2. Aniline. NH2, aromatic primary amine, having 2,4,6 tribromo aniline. This is Y. This upon bromination, that means on bromination, that means starting X will be obviously aniline. Starting X will be aniline. So this is X. So we have to tell what is X. X is aniline. X is aniline. Very, very simple. After that, you have to match column 1 with column 2. Butane, N-butane and 2-methyl propane. That means one is its isomer. These two are isomers of each other. That means you have to convert one isomer into another. That means it is what we call isomerization. So A is 3. A is 3 means option number 1. A is 3 means option number 1. Now, let's check B as well. This reaction is free radical substitution reaction. What about this? This is decarboxylation reaction. That means B is 1, C is 4. B is 1, C is 4. Obviously, D is Wirtz reaction. D is 2. Obviously, D is 2. Simple reactions. Now, cyclohexene. Cyclohexene is this one. Cyclohexene on ozonolysis. On ozonolysis. Followed by reaction with zinc dust and water. That means reductive ozonolysis. We know upon reductive ozonolysis, break this, give double bond O to this, give double bond O to this. That means our product will be like this. So this is the product of ozonolysis. This is the product of ozonolysis. Okay. Now, so this is compound E. Now it says compound E on further treatment with aqueous KOH. On further treatment with aqueous KOH. Then yields compound F, then it yields compound F. So this is normal, what we call aldol reaction, but as there is no amine to say beta hydroxyaldehyde, so we can simply heat it, and so that we will form, let's say for example, this is 1, 2, 3, 4, 5 and 6. Let's say this is alpha position, second is alpha position. We will remove 2 hydrogens from alpha and double bond O from 6th position. That means I will form a 5-membered ring. And to this 5-membered ring, listen carefully, it should be CHO at 1 position. Let's suppose CHO is this carbon number 1. That means this is carbon number 2. I have formed a double bond between carbon 2 and 6. Let's suppose this is 6. Then obviously this is carbon 3, 4 and 5. 4, 5 and 6. That means there should be a 5-membered ring. Double bond should be there between carbon-carbon double bond, and to that double bonded carbon CHO should be attached. That means it's option number 1. It's option number 1. And this reaction is intramolecular aldol condensation. I hope this point is clear to you. I hope this point is clear to you. After that, a compound A is a compound. Have a look. This on treatment with something results in the formation of phenyl hydrazone. Phenyl hydrazone. That clearly indicates this A having formula this C5H10O. It can be either aldehyde or ketone, which on treatment with what we call phenylhydrazine gives phenyl hydrazone. Now, and gives negative tolerance test, but it gives negative tolerance test. That means it can never be an aldehyde, so it can be a ketone. After that, it gives positive iodoform test. Positive iodoform test means this ketone should contain CH3C double bond O group. That means it should be ketone. It can never be option 3 because this is aldehyde. It can never, okay, it can be 1, 2 or 4, but according to this, it should have CH3CO group. This is having CH3CO group, so it can be it. It can never be this because it can never show iodoform test. This is also having CH3CO, so it can be 1 or 4. But compound A on Clemmensen reduction, this on reduction gives N-pentane. This on reduction gives N-pentane means this C double bond O is converted to CH2. So it is option number 1 because it gives N-pentane. It will not result in the formation of N-pentane. After that, we are having another question. Have a look. It's very simple. This is having negative part, this is having positive part. This negative part will attack this and this bond will be broken. After that, what will be the product? What will be the product over here? First, we will result in the formation. It will result in the formation of this one. First, it will result in the formation of O minus. Then it is MgBr with a positive charge, which will be attached to this. And here it becomes CH3. But upon hydrolysis, it will result in the formation of, let me erase this one. It will result in the formation of OH. So this is RA. This is A. This on treatment with HBr, that means OH will be replaced by Br. So it will result in the formation of this one. This is beta RB. Now, this on treatment with magnesium, what will result? It results in the formation of compound C, and that C is always, whenever you are having CX bond and magnesium is there, so MgBr will be like this. This MgBr is having positive part and this ring and what we call CH3. That means this part is having negative part. This negative part will attack CH3CHO. So the final reaction is like this. It will be like this. MgBr. This is having positive part. This is having negative part. This on treatment with CH3C double bond O and H. What will happen? This whole negative part will act as a nucleophile. It will attack this one. Now, this becomes CH3, CH, and this becomes O minus MgBr with a positive charge. And to this, it is this carbon, say this 6-membered ring, which is attached because this carbon is having negative charge. This will form a bond. And to this, there is CH3 as well. Finally, hydrolysis takes place. So it will result in the formation of this 6-membered ring. To this, it is CH3. Then it is CH, OH, and CH3. That means there is a carbon of this ring to which CH3 is attached and this isopropyl alcohol group is attached. That means it is this one. It is option number 1. 6-membered ring, and to one of the carbons of 6-membered ring, there is CH3 and CHOH CH3. CHOH CH3. Yes, it's option number 1. So option number 1 is the right answer. Is this point clear to each and every one? It's not 3. It can never be 3. It can never be 3, beta. Have a look, have a look, have a look. It is this point. It is this carbon which is attached to carbon. That means it is the same carbon of cyclohexane to which CH3 is attached. To that, it is CHOH and CH3 which gets attached to that. So it is option number 1. Okay. Now, after this, is this visible to each and every one? Is this question visible to each and every one? Let me check. Let me check. Yes, this is visible to each and every one. Now, what is this? This is an unsymmetrical alkene, B2H6THF. That means it is what we call hydroboration oxidation reaction. We know whenever this reagent is there, whenever hydroboration oxidation reagent is there, whenever hydroboration oxidation reagent is there, you have to add water. You have to add water across carbon-carbon double bond. Across carbon-carbon double bond according to anti-Markovnikov's rule. Anti-Markovnikov's rule. That means negative part should go to this. That means to this position it should become, say CH2H. This position should become CH2H, and to this position H will be added. That means it becomes CH2. So it is option number C. It's option number C. It's option number C. I hope this point is clear. After this, in the following pairs of halogen compounds, which compound undergoes faster SN1 reaction? In this is secondary alkyl halide, this is tertiary, so obviously it will be this tertiary one. In this, it is secondary one, it is primary one, so obviously it is secondary one. That means first tertiary, and then secondary. That means it's option number B. It is option number B. After that, because rate of SN1 is directly proportional to stability of carbocation. After that, hydrolysis of benzene diazonium chloride. Hydrolysis of benzene diazonium chloride will result in the formation of phenol. That means A will result in the formation of 4. A will result in the formation of 4 means it is this option. But here you can check others. Phenol plus methyl chloride in presence of what we call anhydrous AlCl3. That means this is Friedel-Crafts, what we call this is Friedel-Crafts alkylation reaction. That means methyl will be attached to, say phenol. Major product will be obviously para product. So this is paracresol. That means B is 3. B is 3. No, not B is 3. B is 1. B is 1. Sorry. B is 1. Reaction of sodium phenoxide with carbon dioxide. This is simply coal base, what we call Schmidt reaction. So it results in the formation of salicylic acid. So C is 2. C is 2. Then phenol plus concentrated HNO3. It results in the formation of picric acid. That means it is D, which is 3. So obviously this option 3 is the correct answer. After that, dear students, what will be the product over here? Very, very simple. First, it is acetylation. That means first reaction will be like this. First reaction will be like this. It will be acetylation to this. That means replace H by acetyl group. Replace H by acetyl group. Simple. It will be like this. So this will be the product when this para-methyl aniline is treated with acetic anhydride. This will be the product. After that, it is bromination. After that, it's bromination. That means second product. Let me write down over here. Second product will be like this. Second product will be like this. Second product will be like this. Bromination will take place at this position, ortho position, because this is more, say, orthopara directing as compared to this one. Stronger orthopara directing as compared to this. So electrophile will take the position of ortho and para with respect to this, but para is blocked, so it goes to ortho position. Now after that, hydrolysis. After that, hydrolysis. Hydrolysis will result in the formation of this one. This group will be lost. Hydrolysis. Hydrolysis will result in the formation of this one. So this is after hydrolysis. Then it is treated with NaNO2HCl. That means convert this NH2 into diazonium salt. Convert NH2 into diazonium salt. Convert NH2 into diazonium salt. That means it will result in the formation of this one. After that, H3PO2. The function of ethanol and H3PO2 is same with respect to diazonium salt. It will replace diazonium salt by hydrogen. That means N2 group is replaced by hydrogen. So the final product is this one. Final product is metabromo, what we call toluene. That means final product is option number C. final product, my dear students, is option number C. After this, paranitrophenol is a stronger acid than phenol with, while, it's not with, it is basically while. It is while. Okay, while paracresol is a weaker acid, this can be explained on the basis of CH3 group decreases electron density. No, it increases electron density. NO2 group decreases electron density of oxygen. Yes, electron density, because NO2 is electron withdrawing. It decreases electron density of O. When it decreases electron density of O, so H can be released easily at that time. So it becomes, I mean to say, it becomes what we call more stronger acid. So option B is the correct answer. CH3 group increases electron density on this, making release of, no, it's wrong. NO2 group increase, no. So option 2 is the right answer. After that, have a look. First, it is aniline on treatment with, I mean to say, NaNO2HCl. This is simple diazotization reaction. It will result in the formation of this. It will form benzene diazonium salt. Now this benzene diazonium salt on treatment with CuCN KCN, it is CuCN KCN. That means it's normal Sandmeyer reaction. Normal Sandmeyer reaction. What will happen in Sandmeyer reaction? N2 will be replaced by cyanide. So benzonitrile will be obtained. Then after that, it is benzonitrile. I can write down this in this fashion. Now this upon treatment with sodium amalgam in presence of ethanol, this is Mendius reduction. What will happen? Here reduction will take place and it will convert C triple bond into C single bond N, then add hydrogens, 2 hydrogens to carbon, 2 hydrogen to nitrogen. That means finally product will be like this. So this is the final product of the reaction. There, which of the following is aromatic? This can never be aromatic because of this sp3 hybridized carbon. So it is this which is aromatic. This is having sp3 hybridized carbon, that's having sp3 hybridized carbon, which clearly indicates in 1, C and D, there is no complete cyclic conjugation. Complete cyclic conjugation is here and it's having 6 pi electrons. So this is what we call aromatic. After that, N-butane to 2-methyl propane. This is already done. This is already done. This is isomerization because A is 3. This is already done. A gives 3. This is the question which has been repeated over here. So it is A3. Others, they are very simple. This is what we call free radical substitution. This is decarboxylation. This is Wurtz reaction. This is done. This is done. After that, okay. There are two functional groups and this is principal functional group. First thing, when your compound is having polyfunctional groups, at that time, you have to identify principal functional groups. So it is like this. Numbering will be like this. So this will act as a substituent, but its carbon is included. So it is oxo. So it is 6-oxo and this is 2-methyl. So 2-methyl and 6-oxo. Where is 2-methyl and 6-oxo? Is there any 2-methyl 6-oxo? Yes, it is option number 3. So it is 2-methyl 6-oxo. After that it's hex, then it is 3N, hex, 3N, and then amide at one position. So you can write down 3N amide directly. Okay. After this, statement question. Nucleophilic addition of sodium hydrogen sulfide to an aldehyde or a ketone involves proton transfer to form a stable anion. Exactly correct. Statement second. Nucleophilic addition of hydrogen cyanide to an aldehyde or a ketone yields amine. No, this is wrong because addition of HCN to aldehyde or ketone results in the formation of cyanohydrin. Statement 1 is correct. Statement 2 is incorrect. That means statement 1 is true, but statement 2 is false. So it is option number 4. After this, my dear lovely students. Now, benzaldehyde cannot be prepared by. Have a look. This is very, very simple. This is very, very, very simple reaction. Tell me what should be the answer of this question. This is very simple. Tell me what should be the answer of this question. This is very simple. Come on, quick. Let me know in the chats what should be the answer of this question. This is very, very simple question. Very, very, very simple question. Great, great. Now have a look. First reaction is Gattermann-Koch reaction. We know whenever benzene reacts with COHCl in presence of AlCl3, it results in the formation of benzaldehyde, and this reaction is known as Gattermann-Koch reaction. If we talk about third reaction, this is reaction of toluene with chromyl chloride followed by hydrolysis. This is Itard's reaction. This also results in the formation of benzaldehyde. Now, what about this? This is known as Rosen-Munz reduction. This also replaces the Cl by H. That means it also results in the formation of benzaldehyde. But this can never form a benzaldehyde because zinc amalgam HCl generally does not react with what we call carboxylic acid. So option B is the right answer over here. This is actually, the wrong one, and After this, question says, number of pi bonds, 1, 2, and 2, 4. That means you have to tell me how many number of pi bonds are there. So answer is very simple, it's 4. After that, which is incorrect statement? Let me know the answer of this question quickly. Let me know the answer of this question quickly. Let me know the answer of this question quickly. I want to check how many among you can give me the right answer. Quick. What will be the answer of this question? What will be the answer of this question? Quick. Quick, my dear lovely students. Quick. What will be the answer of this question? That's great. That's great. Many students are giving right answer. Have a look. This is first and this is second. Question says, have a look. You know E and Z. According to E and Z, this is having first priority, this is having second priority, this is having first priority, this is having second priority, 1 priority, identical priority or on the same side. So obviously this is Z. Now this is having 1, this is having 2, this is having, this is having 2, now this is having 1, this is having 2. Identical priorities are on the opposite side. So this is E. Question says 1 is having Z configuration. This is correct. Second is having 2 configuration. E configuration. This is also correct. But what we have to do is we have to find out which is incorrect. That means first 2 are correct. Then these 2 are 1 and 2 are geometrical isomers. This is incorrect because they are not geometrical isomers. What are geometrical isomers? Geometrical isomers are first of all stereoisomers. And what is meant by stereoisomer? Whose structural formula and molecular formula is same. Molecular formula is same, but their structural formula is not same. Why? Because connectivity is different. Have a look. To this carbon, it's bromine and iodine, but to this carbon, it is iodine and chlorine. That means connectivity is different. That means they are having different structural formula. Different structural formula means they can never be stereoisomers, so they can never be what we call geometrical isomers. After that, question says, the correct order of the acidic strength of the following compounds. Correct order of the acidic strength of the following compounds. What is phenol? Phenol means this one. Phenol means this one. What is cresol? Paracresol. Paracresol means it is basically phenol to which methyl is attached to para position. What is meta-nitrophenol? Once again it is phenol, but to this phenol its electron withdrawing group meta group is there. What is para-nitrophenol? Once again a phenol, but it is having NO2 group at para position. This NO2 shows -R, this shows -I. This is neutral phenol. This is what we call having a plus H group. So remember, we know acidic character. As per acidic character is considered, we have to write down first -R, then -H, then -I, then neutral, then +I, then +H, then +R, my dear lovely students. Now, you have to write down this strong to weak first. Here, weak to strong first. Now, we have to write down first, -R. -R is para-nitrophenol. That means it is D. D. That means it's only one option where D is at first position. Obviously, after -R, -H, but -H is not there. After that, -I is this one. So first D, then C. After that, neutral. Neutral is this one because the groups attached to benzene ring, apart from OH, is only hydrogen, and hydrogen shows neither of these effects when it is attached to benzene ring. Now, it is this one, A. So D, C, A, and finally it is B. I hope this point is clear. Now, consider the following compounds. Compounds are given. These are amines. Aniline is. Arrange these compounds in decreasing order of their basicity. We know among basicity or the strength of base, we have to write down first +R, then +H, then +I, then neutral, then -I, then -H, then -R. First, write down strong to weak. Here, write down weak to strong. That means this is opposite to that of what we call acidic character. Now, have a look. Have a look. If we talk about this, aniline is not having any group attached to, say benzene ring, only hydrogens are there, so this is neutral. What about this NO2? It will show -R from para position, it will show -I here, and it will show +H here. So we have to write down first +R, but +R is no one, then +H. Which one is +H? Have a look. Which one is +H? +H is, D. So write down D first, but there can be either 3 or 4. After D, write down neutral. Because after +H, it is +I. +I is no one, then neutral. That means DA. DA. This is DA. This is DA. Now, after that, -I. -I is C. That means DAC. That means it should be the answer. -I and then -R. That means DACB is the right answer. DACB is the right answer as per amines are concerned, as their basic character is concerned. I hope this point is clear. I hope this point is clear. Now, let me know in the chats, what will be the stability of these carbocations? Let me tell you, stability of carbocation is similarly plus R first, plus H, then say plus I, then neutral, then minus I, then minus H, then minus R. Tell me what will be the answer. Tell me what will be the answer. Very, very simple. Very, very simple. Very, very simple. This is having plus R group. This is having plus R group. This is having plus H group. This is having minus I. Then here, if plus R are what we call more than 1, if plus R in these options are more than 1, you have to write down strong first, then weak. Here, if they are more than 1, then weak to strong. Now, plus R are there in two groups, say in P option as well as in Q option, but we know plus R of NH2 is stronger than plus R of OH. So we will write down Q first, then P. Q, then P. That means these two can be the options. After that, it is R. So Q first, then P, and then R. Q, P, R, after that S. So it is option number 4. Q, P, R, S. It is option number 4. I hope this point is clear. I hope this point is clear. Q, P, R, S. It's not C. It's not C. It's first Q, then it's P, because strong plus R, weaker plus R, after that plus H. After that plus H, it is R. Then minus I, then minus I. So we will write down like this. We will write down like this. After that, a very simple question. A very simple question. Paper chromatography is an example of what? It's a partition chromatography. It's partition chromatography. Very simple. Now, question says, if you are having a 5-membered ring like this, if you are having a 5-membered ring like this, then addition of HBr will take place in this fashion. Br minus will be lost. So first it will result in the formation of a carbocation like this. Then ring expansion will take place. Ring expansion will take place. This bond will break and it will form a 6-membered ring like this. So let me show this in this fashion. Let me show this in this fashion. So can I say this is a 6-membered ring? Can I say it's a 6-membered ring? And to 6-membered ring, there are 2 methyl groups. To 1 methyl group, there is a positive charge attached. I hope this point is clear. Now, after this carbocation is a stable carbocation, because if you, say replace hydride from this to this, if you shift hydride from this to this, same type of stability of carbocation will be formed. Then finally, Br minus will attack to this, and we will get this product. We will have this product. We will have this product. That means we will have 1 bromo, 1,2-dimethyl cyclohexane. 1 bromo, 1,2-dimethyl cyclohexane. This is bromo basically. This is bromo over here. So 1 bromo, 1,2-dimethyl cyclohexane. C is the right answer. C is the right answer. Say 3 option, third option is the correct one. Now tell me, which of these options is correct in this? First of all, it is HgOAc whole 2. But here it is not water, it's alcohol. Now what will happen? What will happen over here? Have a look. It will result in the formation of this one, HgOAc. If it is water, then negative part of water. But instead of water, what is this? Alcohol. Negative part of alcohol will be added over here. Negative part of alcohol is OR. This is negative part. After this is treated with NaBH4. So this step is known as alk oxymercuration. Instead of oxymercuration, alk oxymercuration. Why alk oxy? Because alkyl and oxygen has been added and mercury has been added. So alk oxymercuration. This is known as reduction or demercuration step. This is reduction or demercuration step. That means removal of mercury will take place over here. Removal of mercury. Remove mercury and add hydrogen. Remove mercury and add hydrogen there. So what will be the product? Ether formation will take place. That means it is option number C. Option number 3. Third option is the correct reaction. So this reaction is known as alkoxymercuration demercuration. It's basically type of oxymercuration demercuration. Only thing, in case of oxymercuration, there is water. We will add negative part of water. That means OH minus. But here it's alcohol, so add negative part of alcohol. After this, the reaction of this with HBr, have a look. We know it first results in the formation of a carbocation, and here carbocation will be more stable. That means, first of all, what will happen? Have a look. it will result in the formation of this one. I have formed a resonating structure over here. On treatment with HBr, what will happen? This bond, say abstracts HBr will be lost and a carbocation will be formed. But here, carbocation will be more stable because of resonance of this. I hope this point is clear. So, here will be carbocation which will be more stabilized. That is why I will add hydrogen here and will form a carbocation, more stable carbocation over here. Now, this is very much stabilized because of resonance. Finally, dear students, Br minus will attack this one. Br minus will attack this one and we will get CH3, CH2, then CHBr and then this phenyl ring to which OH is attached. I hope this point is clear to you. That means it should be phenol ring. It should never be this. That means it can be this, this and this. But to this phenol ring, the carbon which is attached to benzene ring, to phenol ring, say this ring, there should be Br. That means it's option number. It can never be the option. Option number 2 is the right answer. Okay. Then, phenol on treatment with A. Phenol on treatment with sodium hydroxide results in the formation of A. So this is Ra. This is sodium phenoxide. This is A. This A on treatment with carbon dioxide, 300 degrees Celsius, 6 to 7 atmospheric pressure, results in the formation of, this is coal-based Schmidt type, Schmidt reaction, coal-based Schmidt reaction. So it will result in the formation of this one. This is B. On hydrolysis, on acidification, it results in the formation of salicylic acid, orthohydroxybenzoic acid. So this is what we call our C. This on treatment with acetic anhydride, acetylation will take place. This H will be replaced by COCH3 and this COH will be there. This is D and this is known as aspirin. This is aspirin. Now you have to tell me what is D. D is aspirin. That means it's option number 1. After that, dear students, have a look. It is nitrobenzene. Is this visible? Is this slide visible to everyone? First of all, yes, this is very much clear. Now, have a look. This is nitrobenzene. Nitrobenzene on treatment with tin HCl. That means NO2 is reduced to NH2. That means this X is aniline. This aniline on treatment with NaNO2 first. First, it results in the formation of benzene diazonium salt. It first results in the formation of benzene diazonium salt. This benzene diazonium salt on treatment with CuBr, that means cuprous bromide. This is simply what we call a Sandmeyer reaction and we will get bromobenzene. So this N2 will be replaced by Br, so we will get bromobenzene. So what is X and Y? X is aniline, so it can never be X, it can never be X, it can never be X. This is aniline. X is aniline and this is our Y, Y is bromobenzene. That means option B is the right answer. Then my dear lovely students, a very simple question. A very, very, very simple question. Now this is having, have a look. This is aldehyde having alpha hydrogen. Aldehyde with alpha hydrogen on treatment with, sodium hydroxide first results in the formation of aldol, which upon heating gives alpha beta unsaturated aldehyde. That means that is basically aldol condensation. So I will show the product of this. That means it will result in the formation of pH, CH2, C double bond OH, plus it is H2, this one, CH2, then it's having pH, then it's having, CHO as well. What will happen? Water will be lost. It will result in the formation of pH, CH2, CH, double bond CPH, and then it is CHO. Or I can write down this pH over here and CHO over here. So let me write down CHO over here and pH over here. Is this point clear to you? Is this point clear to you? Now, after that, this on treatment with H2Ni. That means reduction will take place. This H2Ni can reduce carbon-carbon double bond. It can also reduce aldehyde. So it will result in the formation of pH, CH2, CH2, CH, single bond pH, and this will become CH2OH. I hope this point is clear. So it is option number 2nd is the right answer. Okay. After that, there is a question, a very, very good question. You have to tell me what is X. But before that, What is this? This is alpha beta unsaturated carbonyl compound, and this is base and heat. That means this has been formed by aldol condensation. That means you have to go backwards. So retroaldol. How to do retroaldol? Break alpha beta bond, and give 2 hydrogen to 1 carbon and oxygen to another carbon, because alpha beta unsaturated carbonyl compound has been formed by loss of water. So you have to add water by breaking carbon double bond. Now, this fragment, this fragment contains double bond O, so give 2 hydrogens to this. This does not contain any double bond O, so give oxygen to this. That means this is 1, 2. At second position, there should be double bond O, 3, 4, 5, 6, 7, 8, and 8th position, there should be double bond O. That means this is having double bond O at third position. Now, it is like this. This is having double bond O to second position. This is having double bond O third position. So 1 and 2 can never be. So double bond O should be at second position. But after that, how many carbons? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That means fourth option is correct. 1, 2, 3, 4, 5, 6, 7. No, this is not the correct. So X is, I mean to say, that fourth option. This is simple reaction. This toluene on treatment with bromine, this is what we call benzylic bromination. So it will result in the formation of CH2Br. This CH2Br on treatment with KCN will replace Br, and the major products will be cyanide. So this is major product cyanide. This upon hydrolysis and heat, cyanide group is hydrolyzed to what we call carboxylic acid. So it will result in the formation of CH2COOH. So which one is the correct answer? This is the correct answer, my dear lovely students. Exactly, my dear lovely students. So this is all about for today's session. Thank you and God bless you. Now, after I end this session, we will be waiting, me and Wasim sir will be waiting for your comments. Write down in the comments, how was the session? Do you like the session? And from where you were watching. So take care. Bye-bye. Good night and God bless you all. Thank you and God bless you.